Welcome to Geometry Pre-AP. Today we're going to deal with rotations. And so what you'll want to do is you'll want to get all of this in this highlighted box written down, this, and this essential understanding. So I expect these in your notes every time. All right, so get that in there, pause it, and then start it when you got those things copied down. All right, also I wanted you to copy down this information. This is the basic information about what a rotation is. And so a rotation is a rotation about a point that's an X number of degrees. That point that you rotate about is called a center of rotation. So that's an important thing there. There are properties to a rotation. The image of Q is itself Q prime. And for any other points, V will be V prime. So the distance from Q to V is the same from Q to V prime. And the angle should be the angle created. So this is the angle created by the rotation. Okay, the number of degrees a rotator rotate is called the angle of rotation. And for all intents and purposes, since this is an algebra-based geometry, we pretty much just look at the 90, 180, and 270 degree rotations. Any other rotations have to revolve or involve a protractor and a compass, and we don't really do those right now. Okay. And so they even show you some of the notations that's used. I tend to just tell you to rotate. And by the way, we always do a rotation counterclockwise. This is always the designated way we rotate. Okay? All right. So now, just a few key little ideas. All right, so there is the 90-degree rotation, and so this is the motion rule for the 90-degree rotation. This is the motion rule for a 180-degree rotation. This is the motion rule from a 270-degree rotation. And this is the motion rule for 360. And a 360 is the exact same thing again. So, all right, so these motion rules are also in your formula chart. You don't have to have the graphs, but I at least have each of the motion rules down. You might even want to take the time to go ahead and pick up this part in green. Oh, that's pretty dark. Let's see if I can go a little bit lighter. How about this part right here? Get this part also written. It might do you some good. And actually, you know what? You really probably don't even need either one of those, so we can just get rid of those. 360 rotation is just the same thing anyways. All right, so these are our 3 rotation rules. All right, so if you're actually doing a rotation with a compass and protractor, this would be all the steps. You do not need to write any of this down. I'm just going to pull it out for you to look at, and you can read and see what's going on with it and see how it's done. You can pause the video and read those steps. I'm not going to make you do this in class. I'm not going to make you do this on the test, so you don't have to worry about this. So do not copy this into your notes. I think it even says that up there at the top. Do not copy into the notes. All right. So here's our first practice problem. So it says drawing rotations in a coordinate plane. PQRS has these vertices. What is the graph of the rotation of 90 degrees about the O? There is the origin. Okay, and so we have a motion rule. So the motion rule for a 90-degree rotation is x, y changes to negative y comma x. And there's an interesting reason why that is, and you can ask me about that in class and we can discuss it a little bit. I'll show you where it comes from. All right, and so we find and graph the image of each vertex, use the coordinate rules that describe a 90-degree rotation, and so then we make those changes. So negative yx. So the 1 becomes to the front, so negative 1, and then the 1 moves to the back. And so then we have all our points changed, and we just regraph those points. Make sure that you list each one of those points with the prime notation like they have here. If you don't have that prime notation, we do deduct points for that. Okay, and so then we graph our points. All right, so again, here are the motion rules. These are the 3 that you need to know. They're always rotating counterclockwise. So you can take a second to practice these. So here's a 90-degree rotation and a 270-degree rotation. So if you want to practice those, I'm going to put a star by these. I'm going to show you a couple of the points, but not all the points. Okay, so check a couple points. I'll show you maybe this one and about this one. There's you 2 of the points shown. You should have the rest of those points in your notes. All right, you did not have to copy this down again because you had it from the other page. And you also have this on your formula chart. All right. So here's another practice problem. This one I want you to rotate it 90 degrees counterclockwise. And so for this one here, I'm going to kind of run through the process with you and do the practice with you. So we first have the rule. So x comma y changes to negative y comma x. So my first order pair would be a prime, and that would be the negative 2 comes to the front, it changes the sign, so it becomes a positive 2. The negative 7 moves to the back and just stays what it is. B prime, the 1 in the back, the y, the negative 1 in the back moves to the front, changes its sign, so it becomes a positive 1. The negative 2 moves to the back. And finally C prime, which the negative 8 moves to the front, changes sign, so it becomes a positive 8, and negative 1 moves to the back. And so therefore, if I graph these points, this is what I get. I get 2 comma negative 7. So there's point A prime. I get 1 comma negative 2. That's B prime. And then I get 8 negative 1. That's C prime. And so when I connect those, remember I want you to use your straight edges to make sure you have good points. And so even here, negative 7, 2, this was A, this was B, and this was C. And this is a 90-degree rotation. So this whole figure rotated 90 degrees. So this will move 90 degrees here. Whoops, not that one. This will move 90 degrees here, and this will move 90 degrees there. Okay. All right. So practice this one. Pause the video. Do this problem. Okay. So you should have that one done. We're going to have you do this one too. Practice with this one. I want these graphed, and I want all the points listed. Pause the video. Do that one. Now, when you come to class, ask me about that 180-degree rotation. We can talk about that for a minute. All right, so if we look at this problem, it says find the value of x and y. So this is a 120-degree rotation. Is this a rigid transformation, or is it an isometry? Or is it a non-rigid? So is the shape the same? Well, the shape is the same. So the shape is the same. Parts that are in the corresponding places, so this piece and this piece are the same. This piece and this piece are the same. And this one here is the same as this one here. But we want x and y. So if I look at this one, this x is equal to that 5, and that 3y is equal to x plus 7. Now, we don't have two variables there, but we do know x is already equal to 5. So 3y equals 5 plus 7. 3y is equal to 12, and so y is equal to 4. How we write this answer? If I were you, I'd write it as an ordered pair 5 comma 4, x comma y. All right, so I practiced that one for you. And that wraps up this video for rotations. When you come to class, ask me a little bit about those rotations and the rules, and I can give you a little explanation about where those rules come from and an easy way to remember them.